Alright, welcome back. This is section 1.6 for linear algebra, and we're going to be starting out with question 1 and 2 and go from there. So the first one, basically you're solving the system by inverting the coefficient matrix and using theorem 1.6.2. Ultimately it's nothing difficult. Basically we're just, it's a fancy way of saying, well, let's find out what the solutions are. So give me so this is a given equation for number 1, for instance, right? So x1, x1 and x2. I want to find what those values are. So we've done that before. We've used a variety of different ways to calculate this before. But this is also another method that you should be familiar with. I'd imagine we will see more of this in the application section later on in 1.9 or something. But anywho, right now all we care about is the method. So we so the theory goes something like this. So we think so there ax equals b, where a is the coefficient of the main matrices. So here, if we just did a regular matrix on this, it would be like 1, 1, 2, and 5, 6, 9, right? A will be all the coefficient in front of the unknowns only. So we're not talking about the constants after the equal sign, right? So A will be represented by 1, 1, 5, 6. Just like in front of 1, 1, 5, 6. Only in front of the unknown variables, right? And we're not touching the constants, right? Constant will be B, right? Hence the fact that B is on the right of the equal sign, right? So B will be 2, 9, as shown here, right? X will be it just is the unknown variables, right? And that is our prize here. This is our target. So we just want to isolate the x so that x will equal to something, and all we have to do is just multiply a bunch of matrices to ensure that we get the unknown variables, rather than going through the forgot what it's called, back solution or something like that we did in 1.2 and 1.3 through like elimination processes and whatnot. So I like it. It's pretty elegant. But so let's see how we isolate for x though. We can't just divide b divided by a, right? Because we can't divide the matrices. Which means how do we get rid of a? By timesing the inverse of a, right? So what happens here is, so ax equals b. So I'm gonna put inverse of a in front of both sides, because if I don't do both sides, then it will no longer be considered as an equal sign, right? So if I have inverse of a and a times it together, that's going to be identity matrix, which is essentially just 1, right? So we don't care. That's going to be a inverse times b. So the identity matrix, which we can ignore. So essentially it's going to be x equals to a inverse times b, right? So if that's the case, well, I know what A inverse is. I know what B is. So if I times them together, I should have a nice set of solutions for unknown variables represented by dx. So I proceeded and did just that. So inverse of A. So we already know what A is. So doing inverse is pretty easy. For this purposes, we could use the inverse algorithm that we did it in 1.5. Just to get the job done easier, I just used 2 by 2 inverse formula that we used back in 1.4, 1.3. So so 1 over the determinant, which is AD minus BC. So AD here was 1 and 6, so that's going to be 6. Minus 5 times 1 is going to be 5. So 6 minus 5 becomes 1 over 1. So good, we don't really have to worry about the multiplication then. So and on the main side of the matrix, so we just flip the A and D, flip the signs for B and C, and then this is a B, which is the constants that we were talking about, right? So just times all of this together and it should give us X. Well, let's see if it does. So I just times this, remember it's 2 by 2 times 2 by 1, right? So final dimension should be 2 by 1, right? Remember, so if you have 2 by 1 and times 2 by 2 times 2 by 1, middle cancels out, so it's going to be 2 and 1, right? Which actually is appropriate because there's two unknown variables, right? Nonetheless, if you times it together, you get 3 and negative 1, and then times it by the constant, which is just 1, so it's 3, 1. So the location 3 and 1, right? So that's first one's gotta be x1, and second one's gonna be x2. So we could just summarize our answers this way. x1 is 3, x2 is 1. Pretty simple stuff, right? Ignore these numbers. That's for question 2. But anyways, so yeah, nothing too difficult. Just get familiar with it, right? It gets a little bit more, not harder, but it gets more tedious as we go to other questions. But, let's do number 2 just so that we're firmly grasped on this, right? So the next one is, we have this. I couldn't find the space to fit in the linear equation, so I just made it as a matrices. But you get the idea. It's the same idea, right? 4, negative 3, 2, negative 5 equals to negative 3 and 9, right? So we want to know what. So using the theorem that we just talked about, x, or the set of solutions, will equal to A inverse times B, which will. So again, I use it. So this is gonna be A. X is going to be the set of solutions, and B is going to be negative 3 and 9 over there, right? So essentially that's what I did. So I just find the inverse of the A, which happens to be 5 times, well, I mean, we should be pretty familiar with this now, so I will stop being repetitive. So find the inverse, and then this is a B, times them together, so I have 1 over negative 14, 42, 42. So 42 divided by 14 is 3. Oh, well, there's a negative, so it's taking a negative 3, right? So because of that, this is my solution. x1, x2 goes to negative 3, negative 3, right? So, that's what we're looking for. So in this case, the x1 and x2 happens to have the same value. But, So, we're gonna try we're gonna try things that are a little bit harder. I think doing all of them is a little tedious though, because the theory is simple. I'm gonna try 5. We should do it 6 or 8, at least one of them, because those are the ones with. Let's do 6. Yeah, okay. So this is question 6. So I would imagine that if you can do number 6, I dare say we don't really have to do much other questions for this particular section between question 1 to 8. So I think this is the most hardest and the complicated one. But anyways, let's push it through. Bear in mind, because of the space confinement, I didn't bother writing down row, what the transformation through, row 3 plus row 2 will give you the new row 2. So hopefully my explanation will be sufficient enough for you to follow through. Please practice this. If I was a teacher, I would totally give this. A lot of ways you could make you could make a mistake. But, bear through, and then we should be alright, right? So, anyways, we started off with this equation. Didn't bother writing the linear equation, as always, simply because of the space issues. But it has all the numbers, so that's all we care about, right? So, we chose the, we took the last column out from the original equation, right? The column with the constants, right? So because this matrix is 1, 2, 3, 4, 5, 5 by 5 matrix, right? So if you take the last constants out, which is the 5th column, then we have 4 by 4, right? Which explains here, 4 by 4, right? So then I put the identity matrix here so that we can go through the good old-fashioned inverse algorithm. And this will be fun. Okay, right, so what happened here? So try to follow through, okay? What I did was, see here, leading coefficient. I chose this one to be the leading coefficient because it's 1144. Number's pretty nice compared to other other rows. So, I'm gonna eliminate the 3rd and the 4th line, right? The 4th row, right? So, first one, I times the 2nd row times negative 1. So, 1 times negative 1 is 0. Negative 1, 3. Give me 2, negative 4, 7, give me 3, negative 4, 9, gives me 5, okay? And make sure you do the same thing on the identity matrix. This is where it gets a little confusing, but nonetheless. So, I made sure, so it was like this, so I'm subtracting second row from the third row, so it's going to be -1, so -1 goes right there. Everything else is not affected because the leading coefficient is only on the second column, right? Okay, moving on to the fourth one. So again, it's -1 and this is 1, so I have to just add the second row to the fourth row. So 1, -1 gives me 0. 1, -2 gives me -1. 4, -4 gives me 0. Nice. 4, -6 gives me -2. And then I do the same thing because I'm just adding it this time. 1 goes 1 plus this row. It's going to give me 0, 1, 0, 1. Okay, so what was my next strategy? So I got the first leading coefficient, so I want to get the second leading coefficient on the second column. For this one, I chose, I could have chose the fourth line, but I chose the first line because it just looked better, I guess. So I just, what the first step is, I just times the first row by -1 so that I can get rid of all these negative signs. So you have 1, 2, 3, and 1,000 just becomes -1,000, right? Well, not 1,000, but you know what I mean. -1, 0, 0, 0, right? So after that, we're going this way. I should mention that. This way. Who cares? This looks like a chaos anyway. So, so after I put in, do the first row times the -1, what we're now gonna do is use this to get rid of all other competitors. So for this one, so for the second row, it's 1. So let's do -1. So what I did was -1 times 1 is -1, plus 1 is 0. -2 plus 4 is 2. Alright, it's 2. -3 plus 4 is 1. And I did the same thing. -1 times -1 is 1. So I'm going to add 1 to the second row, which is going to be just this one, right? Next one, I'm timesing the first row by -2. So it's going to be -2, 2 is 0. -2 times 2 is, 2 times -2 is -4. 3, that will give me -1. And 3 times -2 is -6. 5 gives me -1. Okay, and same thing goes here. -1 times -2 gives me 2. So add negative times 1 times 2 -1. Sorry, -1 times -2 is 2. So I'm gonna add this guy to this guy. Everyone else is times 0, so it doesn't matter. So 2 goes in here, so it's gonna be 2, -1, 1, 0. Okay. Hopefully I can be a little bit more articulate. But anyways, so what am I doing after? So first leading coefficient, second leading coefficient, third leading coefficient. So this number seems really, even though this, typically what I would do is I have -1, -1 here, so I would definitely change this into positive. So, just so that it's a nice leading coefficient that I can use to eliminate everyone else. So I'm just going to times the third row by -1, which means it's going to be 0, 0, 1, 1 instead of 0, 0, -1, -1. And here 2, -1, 1, 0. Just times everything by -1, so it's going to be -2, 1, -1, 0. So signs are flipped. And then I was going to use the third row to eliminate all other competitors, but here 21, 21, and 23, they look really appealing. So I'm actually going to use the fourth row to try to eliminate the first and the second row as much as I can, right? So 21, so fourth row is 22, 1. For second row is 1, 0, 2, 1. Hey, numbers already match up, so nice. So what I'm going to do is fourth row times -1 and add it to the second row. So which means -2, 2 gives me 0. -1, 1 gives me 0. 0, 0, so it doesn't affect the first 1, 0. So that's that. Okay, so what I did was I times fourth row with -1, so it's going to be 1, 1 gives me 2, 1, 1, so -1, 1 gives me 0, -0, 0 gives me 0, -1, 0 gives me -1. Okay, good. And then I'm going to use the fourth row to eliminate the first one as much as I can. So I'm just going to do the same thing. Fourth row times -1, add it to the first row. So it's going to be -2, 2, 0. Negative 1, 3, it's going to be 2. 0, 1 will be unaffected because those two are 0. Okay, so it's going to be 1, it's going to be 1 plus negative 1, it's going to be 0. That's going to be negative 1, 0, negative 1, negative 0, 0, 0, negative 1, 0, negative 1. Good. I haven't touched anything else. So, yeah, okay, good. And then I'm gonna use the no, that's all I did, right? So good. So not quite done yet. So now we're gonna go to this step. So what I've done here is I'm gonna be using the third row to get rid of the fourth row as much as I can, right? So 1 goes into 2. So how do I do that? So I'm gonna do the third row times negative 2 and add it to the fourth row. So negative 2, 2, 0. Negative 2, 1, it's going to be negative 1, right? Same thing. So it's going to be the times negative 2. So negative 2 times negative 2 is 4 plus 4 minus 1 is going to be 3. This is going to be negative 2, 1 is going to be negative 1. Negative 1 times negative 2 is 2, 0, 2. 0 times anything is 0, so it just stays the same. Okay, good. So, and what else did I do? So I'm going to use the fourth row because this is the one with the fourth this is the one with the leading coefficient on the fourth column. So I can use that to eliminate everyone else, except the second row, because it's already simplified as much as possible. 1, 1, 0, 0, 0, right? So I'm just going to touch the first and the third row. So it's negative 1. That's 1. So that I can cancel that by just adding it together. So it's going to be negative 1, 1 gives me 0. So this fourth row is only going to touch the fourth column. So I'm not going to bother looking at anything else. So 0, 0, 1, 0. Good. Now if I just added it, so it's going to be 3, negative 2 gives me 1. Negative 1, 1 gives me 0. 2, negative 1 is going to give me 1. 1, 0 is going to give me just 1. Okay, so that's that, and then I'm gonna also use the fourth row to get rid of the first one. So negative 1, 2, so I'm gonna just times it by 2. So negative 1 times 2 is negative 2. Add 2 is gonna give me 0. So I times it by negative 2, so 3 times negative 2 is negative 6. Oh, no, I'm not timesing by negative 2. My bad. Because it's negative 1 and 2. So all I'm doing is timesing by 2. So negative 2, 2, 0. So okay, good. So it's going to be 3 times 2, 6 goes into 0. So that's 6, right? 3 times 2 goes here. So that's 6. And then that's going to be negative 1 times 2 is negative 2, negative 1. So that's going to be negative 3. It's going to be 2, and times by 2 is 4, 0, so that's going to give me, that's going to give me 4. 1 times 2, negative 1, gonna give me 1. Okay, good. So we're almost done. As you can see, it looks really similar to identity matrix. Negative 1 is the only thing that's in the way, so I'm just going to times the fourth row by the negative 1, which will give me 0, 0, 0, 1, and I'm just gonna flip the signs for all these because I'm just times it by negative 1. So it's gonna be negative 3, 1, negative 2, negative 1. So it's gonna be negative 3, 1, negative 2. What? Crap. The sign should have flipped. Right? Oh, no. Come on. Don't do this to me. Something went wrong. Okay, hold on a sec. So, no, wait, hold on a sec. So, 1, negative 2, negative 1. Okay, so, Okay. Yeah, so I think I made a mistake. Let's see. So this is going to be negative 1. Right? So negative 3. Right? Yeah, I switched the sign. Negative 1 is going to be 1. 2 is going to be negative 2. 1 is going to be negative 1. Yeah, that has to be correct. Okay. Oh man, okay. I'm getting nervous now. Okay, so now it's pretty simple. We just rearrange it. Not that we need to, I think. Because we don't, yeah, but nonetheless, I'm just going to do it anyway. So, so I just flip them. So where's the second row is going to be the first row. The second row and the first row is going to switch. So 6, negative 3, 4, 1 goes to the second row. 2000, negative 1 is going to be on the first row. And the third and the fourth row is not going to change. So that's going to be negative 1 as well. That's going to be negative 1 as well. Okay, so hopefully this is the correct inverse function, right? So but again, you can never be sure about this, right? So as I advised before, what you do is you get this inverse, and then times it by the original, and if I did everything right, it's gonna have to give me the identification. It's gonna have to give me an identity function, identity matrix, right? So original matrix times its inverse that we supposedly found. Why am I saying? So inverse matrix that we supposedly found times the original function should give me an identity matrix. The order doesn't really matter, yeah, for this case, right? So, but you could put yeah. Okay, I'm just repeating myself. So okay, so let's try to check. 0 in the middle, so I'm just gonna disregard all the numbers in the middle because 0 times anything is 0. So 2 times 0 is 0. Negative 1 times negative 1 is gonna give me 1. Yes. Okay, so next one is gonna be 2 times negative 1 is gonna be negative 2, and negative 1 times negative 2 is gonna be 2. So yes, 0. Okay, that's the third. So 2 times negative 2 is going to be negative 4, and negative 1 times negative 4, nice. So that's going to be 0 again. So it's going to be 2 times negative 3 is negative 6, and then negative 1 times negative 6 is going to be 6. Yes, so that's going to be 0. Good. Next one, 6 times 0 is 0. Oh, wait. Yeah, 6 times 0 is 0. Negative 3, 1 is going to be negative 3. 4 times 1 is going to be 4. And then 1 times negative 1 is going to be negative 1. 0. Good. Next one is going to be a 1, hopefully. 6 times negative 1 is going to be negative 6. And negative 3 times is going to be negative 3. Ooh, I'm getting a little nervous. 4 times 3 is 12. And 1 times negative 2. Wait, no. Is that right? Negative 6, negative 3, 12. Yeah, that's going to be right. Oh man, I don't like this. It's going to be negative 9, negative 11. Oh, nice. It is this one. Yeah, okay. Nice. Alright, leap of faith. It's one more space. That may not happen the smartest move. Do not do this. Do not erase everything. Because if you... I'm actually pretty confident this is going to be right, so that's why I did it. But anyways, so let's keep going. So this is going to be... So now we're on the third row. 1 times 0 is 0. Oh, second one 0, so I'm just going to disregard the whole second row here, right? So 1 times negative 1 is going to be negative 1. 0, it doesn't care. 3... And then 1 times negative 2. That cancels everything out. Beautiful. Okay? So next one. 1, negative 1. It's going to be negative 1. 0, don't care. 3. And negative 2. Yes! It doesn't work. It doesn't work either. So I'm going to do the third one. That better be 1, right? 1. Negative 2, it's going to be negative 2. 0, don't care. 1, 7, oh crap, 7. 1, negative 4, it's going to be negative 4. Yes, that gives me 1. Good. 1, so negative 3. 0, don't care, 1, 9, and 1, negative 6. Yes, 0. Okay, good. So this looks, yeah, so this is normally where I would stop, but you know what, since we're still recording anyway, let's just check all the way through. Negative 3, 0, yeah, 1, 1, negative 2, negative 2, negative 1, negative 1 is 1, yes, that's going to be 0, negative 3, negative 1 is going to be 3, 1, 1 is 1, negative 2, negative 2, 3 is going to be negative 6, negative 1 times negative is positive 2, so that's going to be 6, negative, yeah, so let's see, 5, 6, yeah, that's going to be 0, awesome. Okay, so that's next one is going to be positive 6, 4, negative 14, and 4. Okay, yeah, that's going to be 0. Good. Okay, last one's going to be 1. Come on, come on. Negative 3, 9, no, 9, and then 1, 4, negative 2, negative 18, and negative 1, that's 6. Okay. 15, 19. Yes, that's going to be 1. Okay, good. So this works. Unfortunately, we're not done yet. Okay, but at least we got that. So remember I know it's been a while, but remember x equals to inverse of a times b. Okay, so we are gonna now process this. Inverse, which turned out to be correct, so that okay, so that's that, and then times b, if you remember from the question, it was supposed to be 0, 7, 4, 6. So if I do that, then I'm supposed to be getting all the solutions. Okay, so let's make that happen. So that's going to be, I don't need this anymore. So it's going to be what? 2, 0, 0, 0, negative 6. Right? 0, 0, 0, negative 6. Next one's going to be 0, negative 3. Negative 3 times 7 is 21. 4 times 4 is 16. And 1 times 6 is 6. So it's going to be 22. Right? Yep. That's going to be 1. 1, 0, 0, 4, 6, 10. Negative 3, 0, 1, 7. Negative 8. Negative 6. So it's going to be, don't get confused, it's going to be negative 7. Okay, so I'm fairly certain that's correct. Yeah, okay, you know what, that looks pretty good. So, okay, so that will be the answer. So, so if I want to be more specific, x will be, well, we could just say that, or technically we could also say w x, y, z, which happens to be negative 6, 1, 10, negative 7. Can we say that? We totally can. Okay, so that wraps up number 6. Alright, so on to number 9. Essentially, we have two linear equations. And then basically all I did was just convert that into matrix. I'm going to be doing that a lot from now on, simply because we should already know how to do that, as if it was in our second nature. So yeah, so I converted here already, and then basically the only trick about the only twist with this is that we have multiple constant value possibilities. So it could be b1 equals to 1, b2 equals 4, or in other situations it's going to be b1 equals to negative 2, b2 equals to 5, depending on what x1 and x2 values are, right? I'm just using x1 and x2 because that's what it says on the book, right? If on a linear equation. But if they would give you that, you can use any unknown variables you like. You could use x and y, which is what I would use, but you know, whatever. You could even use lambda if you want. Come up with like this bizarre symbols. I used to do that and got into a lot of trouble, but whatever. Well, actually not a lot. But anyways, so basically what we're doing is, instead of saying, well, let's try to calculate one at a time, right? Maybe we can use both and shove it into this matrix so that when we, because what happens is when we make these transformations, that same chain should be applied for both these value possibilities and these two value possibilities. So in theory, we should be able to, I mean, here there's only two, right? But the interesting application purpose we could use is, if there's a way to program this, we could put all the possible values, or put it as a function so that, you know, it would represent all the values. And then every time when we make changes, it doesn't matter what value we have, it's gonna automatically give us what x1 and x2 values are. I'd imagine that you would use something like this in a calculator. But anyways, yeah, can't wait to go to the 1.9, I think. That's where we actually learn everything and then hopefully put it into an application. I haven't had a chance to look at it yet, but if we could, that would be awesome, because that's what computer science is all about. For people who are just taking this in the algebra and not in computer science, I apologize for my enthusiasm. It's optimistic and it's very nauseating. I know, but you know, you sort of need that for you know, to make a videos like this. So bear with me, if you will. Anywho, so we're gonna go through this. So yeah, so essentially what I did was I put 1, 4 because those are the constant values, right? But then I put another slash and put negative 2 and 5. And the only reason why I did that is just so that we can make a distinction between. So if there was, like, you know, no line, then some people might make a mistake and think, oh, this is one whole matrix, right? So that's not it at all, right? The only linear equation information is on this side, right? That's why I put a line through it, right? So for example, let's say we had, I don't know, let's say b1, b2. Let's say there was another possible values. And that's, let's say it was like 4 and 5, for example, right? Then, just mark this down. Then basically what I would do is, like, well, I don't want to write on here, but like, let's say these were the matrices, and then you have this value and this value. I'll just put this value again. And, you know, if there's more, again and again, again, and again. All you have to remember is whatever changes I make here, that change applies to this column, this column, this column, this column, right? So, since the changes are even, it doesn't really matter. But anyway, so let's proceed. So I have this, and I'm basically, my goal is to make this into an identity matrix. We've done that before, or reduce it as much as we can. So so what did I do? So what I did was I got the first row times it by negative 3 and added to the second row. So that becomes this guy, right? So leading coefficient 1, get rid of the competitor. And this becomes 17 because negative 3 times negative 5 is 15, plus 2 is 17. And I made the same changes on this side too. Yeah. So anyways, so that's that. So now what I'm going to do is divide. So that's 17. That's going to be my leading coefficient. But I don't want my leading coefficient to be 17. So I'm just going to divide that by 17, which will give you this. But remember, so same applies here, right? And then what I did next was what do I do? Oh yeah, and I used this leading coefficient on the second column to get rid of the negative 5. So all I did was times this by 5 and just add it to the first row, right? As shown here. So if I do that, that 5 disappears. So that's gonna be like, this will become a fraction. Ignore these numbers. I was just like playing. I can't do these calculations on top of my head. So like I scribble things, you know. But like basically what I did was, you know, 1 over 17, right? So times 5, so that'll be 5 over 17, and then top will be 17 over 17, right? 17 over 17, and the bottom will be 5 over 17. And what I did was I was adding it. So if I add them there, that's going to be 22 over 17, and that's what I did. Same thing applies to this one, right? So that's essentially what I did. Okay. The video is getting a little long because of that number 6. That was really fun. So I'll just quit now, and I'll finish the rest of it in part B. So I'll see you back in part B. Keep it up. Well, end is nowhere near the site, but you know, we're getting there, okay?